Recall the properties of exponents. Remember the product rule: if the base is the same, keep the base, add the exponents. For the quotient rule, if the base is the same and it's in fraction form, keep the base and subtract the exponents. Top, take away the bottom. That's a form of division. Power rule, remember power rule is always in parentheses, and you have a little exponent on the outside in the upper right hand corner of the parentheses. You're going to multiply the powers. Remember the zero property rule: any number raised to the zero power equals 1. The negative exponent rule: remember you have to flip any negative exponents that you have. Okay, so in this section we're going to use properties of exponents to simplify expressions. You know, in the real world, there are several different routes you can take to get to a destination, and math is very similar to that. There are often several methods you can use to arrive at the same answer or get the same answers. You just have to figure out which one works best for you or which one you understand the most. So in this particular problem, I'm going to start it off by first using the quotient rule. Recall the quotient rule is when you have it in division form or fraction form, if the base is the same, which it is, the base is y, it's going to be top, take away the bottom, which means it's going to be -10, take away 1. Now, you know, when you don't see anything in terms of a exponent, it is assumed that it is a 1. Okay, so it's understood that it has an exponent of a 1. So top, take away the bottom. When you combine that, it's going to give you -11. So y to the -11, the problem here is the reason why we're not done is because we have a negative exponent. Recall the rules: whenever you have a negative exponent, simply write it as over 1 and then flip it. So what you'll wind up having then is 1 over y to the 11th. You could have also solved it using the negative exponent rule. With the negative exponent rule, the rule is that you can have a negative. So if you do have a negative, and in this case you do, y to the -10, you would flip that. You only flip what is negative. The y under the bottom does not have a negative exponent, so please do not flip it. You leave it exactly where it is on the bottom. So 10 is going to go to the bottom and join the y that's already there. So you say, well, what goes on top? Well, we can put a 1 as a placeholder there for on top. So now all we have to do is to simply use the product rule for the bottom. Recall the product rule: when you're multiplying terms, if the base is the same, keep the base and add the exponents, and that gives you 1 over y to the 11th, the same answer you got using the quotient rule. So again, whatever method works best for you or that you understand the most, then feel free to utilize that method. Okay, in this example, we're going to use the properties of exponents to simplify the expression. So let's start out with the quotient rule. So with the quotient rule, we recall that when you have it in division or fraction form, it's top, take away the bottom. But in order for you to use that property, you need to get it to where you have one variable or one term on top and one term on the bottom. Well, on the top, we need to consolidate that. So we can use the product rule, which states that when terms are multiplied, if the base is the same, keep the base and add the exponents. So that would give us a to the 4th power on top. And now that we have one term up top and one on the bottom, one variable there, we can use the quotient rule. If the base is the same, which it is, a, keep the base and its top, take away the bottom. So that would be 4 take away -5. 4 take away negative 5. Negative 5, you have a double negative there. Okay, negative 5, but with a negative in front of it becomes plus 5. And so 4 plus 5 will give you a to the 9th power. We can solve this using the negative exponent rule. On the bottom, we have a negative a to the negative 5th power. And you only flip the part that's negative. So if we take that and move it up to the top with everyone else, so 5 is going to join the a's that are already there. So now we can use the product rule and add all of the a's that are here. So we have 3 plus 1, which is 4, plus 5, and you still have a total of 9 a's. So the answer is a to the 9th power. In this example, we're going to use the power rule. Recall the power rule is whenever you have your term in parentheses and there is an exponent in the upper right-hand corner of that parentheses. So we're going to go ahead and raise everyone to that power. That's going to be 4 to the negative 2 power, and then x to the negative 2 power, and then y to the negative 2 power. When we do that, it's going to look like so. Now, you know we can't have negative exponents in algebra. The answer is considered not simplified. So guess what? Since they're all negatives, everybody's going to have to go to the bottom. So you can write it as a fraction over 1, move everyone to the bottom, and move the 1 up top. And then it will look like so. We're almost done. All we have to do here is just solve the coefficient part. So 4 squared is what? Yes, it's 16. So that leaves you with 1 over 16x squared, y squared. There you have it. In this example, we're going to simplify the expressions using the properties of exponents. So for this particular example, we can start off by simplifying using the power rule. Here we have a term that's raised to the 3rd power, and then it is within parentheses raised to the 8th power. So whenever it has a power and then there's an exponent on the outside, remember the rule says to go ahead and multiply those two numbers. So that would give us m to the 24th power. That's the power rule. What do you think we're going to do next? Well, we could consolidate the top and get it to where we have just one variable. So we have m to the 24th, and m, we can use what is called the product rule, is when you're multiplying two terms, if they have the same bases, the rule says that keep the base and add the exponents. So when we add 24 plus 1, that's going to give us 25 on top. And now we can apply the quotient rule. So yes, this problem has a little bit of everything in it. So applying the quotient rule states whenever you have it in this form, which is a form of division, fraction form, if the base is the same, keep the base. Top, take away the bottom. And that's going to leave me with, you got it, it's going to leave me with m to the 13th power, and there you have it. In this problem, we use the power rule, we use the product rule, and we use the quotient rule to simplify this expression. More power rule. Let's apply the power rule to these two examples. So here we have x to the 4th power. It already has a power, so we're going to multiply it with what it's raised to. So that's 4 times negative 7, which is going to give us negative 28. And then multiply the y's. That's going to give me y to the negative 21. You know, in algebra, we can't keep those negative exponents. So what do we have to do? Yes, you got it. We got to flip it. That's called the negative exponent rule. So write it over 1, and they will go to the bottom, and 1 will be on top. And that leaves you an answer of 1 over x to the 24th, y to the 21st power. Next example, let's go ahead and apply the power rule to multiply these exponents. Negative 1 times negative 8 equals positive 8. For b, positive 4 times negative 8 equals negative 32. So we have a to the 8th and b to the negative 32. Let's take a look at our terms. There is one problem here. Remember, we can't have a negative exponent. Only b has a negative exponent, so we're going to leave a alone. We're not going to do anything to a. We're not going to move a to the 8th power. Let's write it as a fraction over 1. So we're going to move b to the 32 down to the bottom. A to the 8th will remain on top. And there you have it. Simplifying expressions using the properties of exponents. In this example, we're going to solve the expression using the properties of exponents. Let's solve it first by using the quotient rule. So here with the quotient rule, then if you're going to use that rule, then you need to consolidate the bottom and get it to where you just have 1x. So let's first apply the product rule. The product rule states that when you're multiplying two terms that have the same base, keep the base here of x and add the exponents, and that's going to give us x to the negative 10 on bottom. Now we can go ahead and apply the quotient rule, which states that when it's in division or fraction form, you keep the base here of x and its top take away the bottom. That's going to be 1 take away negative 10. Negative 10, but with a negative in front of it, becomes plus 10. And 1 plus 10 equals 11. So the answer is x to the 11th power. Let's solve this same problem using the negative exponent rule. For the negative exponent rule, remember you can't have a negative, so what you do is flip it. We only flip the part that is negative. The bottom is negative, which means it's going to go on top and join the x that's already there. We can use a placeholder of 1 on the bottom if you like. And now that all of the x's are on top, we can use the product rule, which states when you're multiplying terms, if their bases are the same, keep the base and add the exponents. So when we add them, that's going to be 1 plus 7 plus 3, which is a total of 11. So you have there x to the 11th power. In this example, we're going to simplify this expression using the properties of exponents, and sometimes you may use several rules to simplify an expression. Let's start this off by using the power rule. Remember, power rule is when you have an expression in parentheses, and on the outside of the parentheses, you have an exponent. So you're going to raise everybody in the top here and everybody in the bottom to that power because we have a fraction inside. So let's go ahead and start with the top. That's going to be x to the, multiplying those, negative 2 times 2, that'll be x to the negative 4. Let's do the y's, y to the 8th power, and that will be on top. Let's go to the bottom. That's going to be x 3 times 2, so that'll be x to the 6th power. For the y's, 7 times 2, that's going to be y to the 14th power. Next, we can solve this using the quotient rule. If the base is the same, when it's in fraction division style, keep the base, and it is top take away the bottom. We're going to subtract those exponents. So for the x, top take away the bottom, y, top take away the bottom. That's going to leave us with x to the negative 10 and y to the negative 6. The problem here is those negatives. Remember, you cannot leave your answer with negative exponents. So you're going to flip it. You can write it as a fraction over 1, and they go to the bottom. 1 will come on top, and that will leave us with a final answer of 1 over x to the 10th power, y to the 6th power. There you have it. Last example, we're going to simplify this expression using the properties of exponents. So we can use a combination here of the quotient rule and the negative exponent rule to solve it, whatever works best for you. For the quotient rule, we can use this rule if the base is the same, which they are 3, keep the base and its top, take away the bottom for the 3's, and top, take away the bottom for the x's. So for the 3, that's going to leave us with negative 1. For x, negative 8, but with a negative in front of it becomes plus 8. So positive 8 with a negative 3, positive 8 with a negative 5 is going to give you 3. Lastly, we've got to take care of that negative exponent problem. So let's go ahead, and we're only moving the negative. We're not going to move x to the 3rd power. Leave x to the 3rd power just where it is. So moving that exponent down is going to look like so. And your answer, you can write it as x to the 3rd power over 3. Or we can write it with 1 over 3, so 1/3 x to the 3rd power. This is the same equivalent answer. Okay? We could have also solved this another way. You remember I told you at the very beginning here that there are several routes you can take in solving a problem. We could have solved this just by solving the exponent. 3 squared is 9. So there you have the 9. 3 cubed is 27. You have 27 on the bottom. And then bringing your exponents over using the quotient rule, top take away the bottom, and you'll still arrive at the same answer as well. So it didn't matter exactly which route you took, as long as you apply or use the properties of exponents. That's the main issue here, is just use any of the properties and you should be fine.